So, number 1 on your coordinate quadrilateral sheet is already graphed for you, just like it will be on your test. So you don't have to take the time to graph the points and label them. Okay? So we want to know what kind of quadrilateral do we have here. Now, what do you suspect it is? A parallelogram. Okay? It looks like it might be a parallelogram. Okay? What else could it potentially be? A kite, maybe. Maybe a rhombus. Okay? Definitely not a square or rectangle, right? And it doesn't appear to be a trapezoid. Okay? But just because it looks like something isn't going to get you any points on the test. You have to show me mathematical proof. Okay? So what I want you to do is I want you to make some triangles here. From negative 0, negative 2, up to 4, 0 is we've gone up 2 and we've gone right 4. Okay? And we've made a right triangle. So when we make a right triangle, rather than use the distance formula to find the length of that segment, we can use the Pythagorean theorem. Pythagorean theorem says a squared plus b squared is c squared. So 2 squared and 4 squared gives me c squared. What's 2 squared? And what's 4 squared? So we've got 4 and 16. So this is the square root of 20. So I need to see that you made a triangle, that you found out, you counted how much vertically and horizontally it was, and how long that side is. Good question. So with the Pythagorean theorem, we have to have at least some parts of it, right? And so you'll be able to go vertically and horizontally on all of these. So you can just count how much am I up and how much am I over, and use the c for your hypotenuse. Okay? Now let's check this other one. If we go down from 0, negative 2, and then over to 4, negative 4, we've gone down 2 and right 4, haven't we? Isn't negative 2 squared still a positive 4? And 4 squared is still 16. And when we add them up, we're still going to get a square root of 20. Does that make sense? Okay. Now, we've got to figure out what's going on with this one. On this side, we have gone right 1, 2, 3, 4, 5, and down 2. So is that going to be the same as a triangle with legs of 4 and 2? No, but let's find out what this length is for this hypotenuse. So what is 5 squared? 25, and negative 2 squared? 4. And 25 plus 4 is 29. So when 29 is c squared, c is the square root of 29. So this one's the square root of 29. Okay. Let's check the other one. Let's make that triangle. We're going down 2 and right 1, 2, 3, 4, 5. So we've got 2 and 5 again, right? That'll make a square root of 29. It depends. If you're going right, it's usually positive, and down is usually negative. Okay? So it makes sense? So is it a parallelogram? Are the opposite sides congruent? No, so it's not a parallelogram. Is it a rhombus? Rhombus means all 4 sides are congruent. So it's not a rhombus. Square is also a rhombus, but it also has 4 right angles. It's a kite. So why do we know that this is a kite? But the consecutive ones are. Opposite sides not congruent. You can put a mark like that to say not congruent, just like not equal has a slash through it. But the consecutive sides are. Okay? Opposite sides are not congruent. Consecutive sides are congruent. That makes a kite. That's our definition of a kite. One of those things you should be studying on your flashcards. But the ones that are next to each other are. That's consecutive. Yep. Yep. This guy and this guy are the same. And those two are. Yep. That's a kite. Okay, make sense? That's the burden of proof you have to give me for your test tomorrow. Okay? We want to make sure that you know slope and you know distance formula and those things so that you can be ready for Algebra 2. All right, questions on this one? Let's do another one together. Number 2. Okay, looks like it might be a square. Okay? We need to verify it. We need to show that it is. Now, this one's nicely oriented, right? Horizontal lines, vertical lines, right? What do we know about horizontal and vertical lines? 90-degree angles. So we've got 4 90-degree angles. So if it's a square, we're close because we've shown that all the 4 angles are congruent. This has a slope of 0. This has a slope of 0, like bunny slope. There's no challenge to that. But can we ski down a slope that looks like this? We can fall, but can we ski down a slope that looks like this? No. So this is our undefined slope. Even Shaun White wouldn't try to ski down something like that. Okay, undefined. Our slope is undefined. Vertical has undefined slope. Horizontal has 0 slope. We're trying to do lots of rise and 0 run. We can never divide by 0. Okay? So we've got 4 right angles. What else do we have to check to see if it's a square? The sides. How long are these sides? 7. 7 for this one between -9 and -2. That one's 7. How long is it this way? 6 and 6. So is it a square? No. It's a rectangle. Why is it a rectangle? What's the burden of proof for a rectangle? Opposite sides are congruent. That also gets us a parallelogram. What's the special thing? 4 90-degree angles. Jimmy, hush. Okay. 4 right angles, so we have a square. Do you understand what I'm looking for tomorrow on the test? Okay. So you're going to work on the next 4. Can we do those? Not a major issue, right? Same idea. Okay, that's going to give you practice for your test tomorrow. Yep. Okay. We have a test tomorrow, and you'll have 3 problems like the ones on this coordinate quadrilateral stuff. Okay. You need to do those 4 problems. I'm going to have you turn them in tomorrow. So we're not going to do anything with the ordered pairs on the review. Okay. So we're going to skip anything that looks like graph these points and tell me if it's a parallelogram. We're going to skip all of those because we have plenty of practice on these. Okay? All right. Questions on this so far? All right, so you're going to finish that. Now, this is the other piece of the puzzle that was missing. Okay, on the first day of this chapter, I had you do an exploration to figure out what happens when we have lots of different polygons. Okay, some of them were triangles, some of them were quadrilaterals, some of them were pentagons, and so forth. And we said, let's break them down into the number of triangles that are inside of them to see what's the total sum of the angles, the interior angles. And I think what happened was we needed one day to just kind of make sense of all of this. And so I hope that this will help do that. Okay. So our first step on all of these kinds of problems is, first of all, to be able to recognize what kind of polygon we have. So across the bottom, I want you to label what each one of these is. As common vocab, you have to know these words. So this first one is a triangle. Okay. Next one, we don't have any special marks here, so what do we have to call this? Quadrilateral, 4 sides quadrilateral. Okay. Then what's a 5-sided? Pentagon. Then 6-sided is hexagon. You have to know that prefix for chemistry next year. Okay, hexagon, hex for 6. Now the next one's close to hexagon, but not quite. Heptagon. Hep. Okay, let's focus, guys, and write these down. Okay, next one, octagon. Nonagon. And then a decagon. Okay. Decagon, decimal, decade all mean 10. They have a prefix of deca or deci. Okay? All right, so first question. How many sides? 7 sides, right? So if it's 7 sides, it's a heptagon. Okay? So this is a heptagon. How many triangles would be inside of it? 5. So 7 is the n, right? 7 minus 2 is 5. There's 5 triangles inside, and there's 180 degrees in one triangle, right? So what is 5 times 180? 900. Okay? So they should add up to 900 degrees. So when you see these kinds of questions, the first thing you ask yourself is, how many sides? And then the second thing you ask yourself is, how many triangles? So how many sides in this one? 5. So how many triangles? 3 times 180 is? So 540 degrees is how much it should add up to. So how do we solve that? How do we figure out what x is? Add them all up and subtract from 540. Okay? So do we need to take the time to actually calculate that, or we're good? Okay? All right. Now, the next piece is understanding that when we have exterior angles, doesn't matter how many sides there are, it always adds up to 360. So exterior kind of looks like pinwheels, right? They always add up to 360 degrees total. Okay? So how would we set this one up if we're trying to find out what x is? All like terms, right? 9x plus whatever we get by adding all of the angles, all the exterior angles, 31 and 41 and 43 and so forth. And then we have to figure out how much they're going to add up to. How many sides are in this particular polygon? 8. It's an octagon. So how many triangles? So 6 triangles. So it's always 2 less. 8 minus 2 gets us 6, right? 6 triangles. So we always lose 1 to the 2 sides that we're triangulating from. And so what is 6 times 180? Got to have a calculator coming up. 1,080. So these add to, oh, hold on. What kind of angles were these? Exterior. So it shouldn't add to 1,080. It should add to 360. Sorry about that. Didn't mean to lead us astray. These are exterior angles, so the exterior always add up to 360. Peyton, did you have a question? So you're going to get whatever this is when you add them up, subtract it from 360 first, then divide by 9. Okay? All right, so whatever these add up to, or we won't take the time for this right now, but whatever they add up to, we're going to subtract that from 360, and then we'll divide it by 9 to get our final answer for x. Make sense? So we had 5x and 4x, so that's going to get us 9x. Those are our like terms for variables. And then 41 and 31 is 72. 15, right? 115 and 5 is 120 plus 5 is 170. So we're at 178, 228, 230, 270. Okay, when I added all those up. So now I want to take the 270 away. So what's 360 minus 270? So x had to be 10. Okay, add up all your like terms and set them equal to 360. All right, questions on that one? Okay. So one thing to remember then, if we have, how many sides is this one? 6-sided. If we have a hexagon, once we find an interior angle or an exterior angle, the interior plus the exterior always add to 180. So do you want to find interior or exterior? Exterior is easy, isn't it? If we take 360 and we divide that by 6, what do we get? 60, so 60. So each exterior angle is 60, isn't it? So what that works with the regular polygons because they have to have the same measure for all the angles. And if 60 is my exterior angle, what's my interior angle? 120. That's the same answer we would have gotten if we had taken our 6 minus 2 times 180 and divided it by 6. Okay, 4 times 180 is 720. 720 divided by 6 is 120. Okay, make sense? Questions on this one? Okay, so your assignment then today is going to be to do your chapter review, which is on page 408. We're doing 1 through 28, and the coordinate quadrilaterals that we were just talking about. But I want you to skip anything that has you graphing and deciding what kind of figure you have. So we're going to skip problems like, let me find them. We're going to skip number 8 and 9. And we're going to skip number 15 and 20 and 23. Okay?